Well, we're looking at points on this curve. We can go ahead and sketch that real quick to just get an idea of what's going on. We've got a parabola, and we're looking at points, and we're looking at the point 3, 1. So 1, 2, 3, 1. And some point on this parabola is closest to that. And so what we're going to do is look at an arbitrary point xy and just come up with a formula for how far it is from that point. So the distance formula is the square root of y minus 1 squared plus x minus 3 squared. And we have our constraint already that y has to equal x squared plus 1. So this is the thing that we are optimizing. And there's our constraint. So we can go ahead and plug in the x squared plus 1. And so d is the square root of, well, x squared plus 1 minus 1, and then squared, and plus x minus 3 squared. So it's the square root of x to the 4th plus, and then we'll go ahead and multiply that out. So that's x squared minus 6x plus 9. Well, now we're taking the derivative of this, so d prime. So this is something to the 1/2, so we pull the 1/2 down and then have all of that to the negative 1/2, and then times the derivative of the inside. That's 4x cubed plus 2x minus 6. And we need this to equal 0. Now notice that this expression here, that's in the denominator, and so it's not going to make this equal to 0. So this is the same thing as saying simply that this 4x cubed plus 2x minus 6 is equal to 0. Okay, and we could divide everything by 2 there to get 2x cubed plus x minus 6. Oh, sorry, minus 3 equals 0. And solving this, there are a lot of different techniques from algebra. I'm not going to go through them, but we could use what's called the rational roots theorem and go through and find out that here x equals 1 is actually a solution of this, and we see that works. 2 plus 1 minus 3 is equal to 0. And now we just need to make sure that that is that does give us a minimum. And so we'll use the first derivative test. We look at a number line, plot 1. If we plug in 0, we get this is positive, and that's positive, and that is negative. So this is positive times negative, which is negative, so it's decreasing. And then if we plug in a 2, we've got that's 16 plus 4, which is 20, minus 12, plus 9, that's positive. And then plugging in 2 there, you get 32 plus 4 minus 6, that's positive as well. And so we have positive times positive, which is positive. So that's increasing, which means we do have a minimum at 1. And so we want the actual point. We found the x value, we need the y value, and y is, of course, x squared plus 1. So 1 squared plus 1, which is 2. So the point is 1, 2.